A car braked with a constant deceleration of 16 feet per second squared, producing skid marks measuring 200 feet before coming to a stop. How fast was the car traveling when the brakes were first applied? Okay, let's see what we can do here. What we have is we have the acceleration function. It's going to be negative 16 feet per second squared. We also have, let's have the velocity at time 0, and that's what we're going to want to find. And so let's go ahead and just call that v sub naught for initial velocity. So v sub naught, and that's what we want to know. And we're going to say our position at time 0 is 0, and that's where we'll measure from. And our position when the car stops then is going to be 200 feet because it has the skid marks for 200 feet. How fast was the car traveling before the brakes were first applied? So let's go ahead first of all and get a velocity function from acceleration. We know that acceleration is the derivative of velocity. So I can find velocity by doing an antiderivative, and that's going to be negative 16t plus initial velocity, because if we put in 0 here, we need to get that initial velocity v sub naught, and that's what we want to find. One of the things we do know is that when the car is finally stopped, that the velocity equals 0. So we could take negative 16t plus v naught and put it equal to 0 and find out at v naught then we have 16t. Or we could solve that for time and say the time it takes the car to stop is the initial velocity v naught divided by 16. Now, having that information, let's go ahead and find a position function from velocity. So here was our velocity, and we know that the derivative of position equals velocity. So that's going to be negative 16t plus v naught. So a position function is going to be the antiderivative of that. That's going to be negative 8t squared plus v naught t. And we can put plus an initial position, but that's going to be 0. If we put 0 in here, we're going to get out 0, so we don't need to put that on the end. It was plus c, but we find that constant is 0. So here is position, and we know that if we take that position and if we let the time be v naught over 16, we will have gone 200 feet. So that's what we're going to do. We're going to have negative 8 putting in v naught over 16 squared plus v naught putting in v naught over 16. When we put that time in, it's going to have traveled 200 feet. So now we just have an equation with v naught that we can solve, and that's what we wanted to know, the initial velocity. So let's see what we have here. We have negative 8 v naught squared over 16 squared, which is 256, plus v naught squared over 16 equals 200. And we can do a little bit of simplifying here. 8 will go in there 32 times. And so we now have negative 1/32 plus 1/16 on our v naught squared. So that is 2/32 minus 1/32. So we have 1/32 v naught squared equals 200. V naught squared equals 6,400 then. And so if we square root that, our initial velocity is 80, and our units were feet per second. Now it didn't ask us to find it in anything specific, and 80 feet per second then would be an answer, but if we wanted to get a sense of how fast that is, we may want to convert that to miles per hour. So we could take our 80 feet per second, and then we could multiply. We've got 3,600 seconds in 1 hour, and we've got 5,280 feet in a mile. 5,280 feet. Don't have a lot of room in a mile. We could do the conversions there, and we would get approximately 54.5 miles per hour.